All right, UMS engineers, welcome back. So for week 2, we're about to unlock a concept that honestly, it's going to feel like a superpower. I'm talking about signal symmetry. This is a tool so powerful, it lets you solve what look like really complex problems, like instantly. And you can do it without even touching your calculator. So how does it work? Let's dive in and see.
Okay, so take a good look at this integral. I know what you're thinking. Your first instinct is probably to just groan, right? And then get ready for a super long, tedious integration by parts session. I mean, it just looks like a ton of work. But what if I told you that you could find the answer to this in like 2 seconds? Seriously.
The answer is 0. Just like that. Instantly, absolutely no calculation needed. So how on earth is that possible? Well, it's not magic. It's something way cooler. It's the power of mathematics. And the secret, the key to all of this, is understanding what we call signal symmetry. And you know what? To unlock this incredible shortcut, you only need to master 3 really simple rules. That's it. Just 3 rules that tell you how even and odd signals behave when you multiply them together.
Okay, so let's break these rules down. As you can see here, the first one is pretty intuitive, right? An even function times another even function, well, that gives you an even function. You can kind of think of it like a positive number times a positive number. Easy enough. And, the third rule is similar. An even times an odd gives you an odd function. That also seems to make sense. It feels logical.
But it's that middle rule that always seems to trip people up. An odd function times another odd function gives you an even one? Yeah, I know, that can feel really counterintuitive. So, you know what? Let's just walk through a quick proof and see exactly why this is true. Okay, first things first, let's just refresh our memory on the fundamental definition of an odd signal. Remember, it's a signal that has anti-symmetry right around the origin. And what does that mean algebraically? It means that x of minus t is equal to times negative x of t. That has to be true for every single value of t. All right, let's walk through this proof step by step. So for step 1, we just define our new signal y of t as the product of 2 separate odd signals. Got it? Okay, step 2. To test its symmetry, we do what we always do. We check it at minus t. Now this brings us to the really important part, step 3. We substitute the definition of an odd signal for both of our original signals. And since they're both odd, each one introduces a minus sign. And then, finally, in step 4, look what happens. Those 2 negative signs, they cancel each other out. Bam! Which leaves us with y of minus t being exactly the same as our original y of t. And that, my friends, is the very definition of an even signal. Pretty neat, right?
So now that we've got these product rules down pat, let's see how they lead to that incredible integration shortcut I was talking about.
Okay, this visual right here shows you exactly why this shortcut works so beautifully. For any odd signal, just look at the area under the curve from minus t to 0. It's the perfect negative of the area from 0 to t. So when you integrate across that whole symmetric interval, what happens? Those 2 areas just completely cancel each other out, and you get 0 every single time. Now, for an even signal, it's a little different. The 2 sides are perfect mirror images, so you can actually simplify your work by just calculating the area of one side and then doubling it. Super useful. All right, the theory is great and all, but let's get our hands dirty and see how this actually works in practice. We're going to solve some problems instantly, just by using these rules. Okay, first up, a classification problem. Now, the challenge here is don't plug in a single number. Just use the rules we've learned. So what kind of symmetry does this function, t squared times sine of t, actually have? Easy. We just break it down into its components. The first part, t squared, well, that's an even function. A good rule of thumb is that any even power of t is going to be even. And the second part, sine of t, that's one of our classic textbook odd functions. So what do we got? We've got an even function multiplied by an odd function. And what do our rules say about that? That the product is always odd. It's as simple as that. All right, and now for the main event. Let's go back to that integral that kicked this whole thing off. Except this time, we have the tools to solve it without even breaking a sweat. So let's analyze the function inside the integral, the integrand. The first component is t cubed. That's an odd function, right? Because it's an odd power. The second component, cosine of t, is our classic even function. So we've got an odd times an even, which makes the whole product odd. Okay, so let's put it all together. We have an odd function, and we're integrating it over a perfectly symmetric interval, from -5 all the way to +5, which means the result just has to be 0. That's it. The answer is 0. And think about it. We figured that out without doing a single tiny step of calculus. All we had to do was check the symmetry first. This is an absolute game changer, especially when you're under pressure in an exam. But look, why is it so important to get this down right now? Because I promise you, this isn't just some neat little trick for your week 2 homework. No way. This is your secret weapon for a much, much bigger topic that's just around the corner. I'm talking about Fourier series. When you get to that in week 4, you're going to be calculating a ton of integrals to find all these coefficients. But if you can spot the symmetry of your signal first, you'll know immediately that half of those coefficients are going to be 0, and you don't even have to calculate them. Just remember this. Even signals only have cosine terms. Odd signals only have sine terms. This will literally, and I mean literally, cut your workload in half. Okay, so to make sure you've got all this locked in, let's do a quick review of the essential skills you've just added to your engineering toolkit. All right, here's your final checklist. First, can you apply all 3 product rules correctly? Especially that tricky one, odd times odd is even. Second, do you know when to use that awesome zero integral shortcut for odd signals? Third, do you remember the half interval trick for even signals to save yourself some work? And finally, just keep this in the back of your mind. How is all of this going to be a massive time saver when you get, mastering symmetry? It's really just the first step. What it proves is that by really understanding the fundamental properties of a signal, you can find these incredibly elegant and efficient ways to solve problems. So as you keep going in this course, I want you to always be asking yourself this one question. What other hidden structures are out there that I can use to work smarter, not harder?